Let us talk about this problem. We are given a number n. Our task is to find out whether the given number is a palindrome number or not. The given number is greater than or equal to 0. A number is called palindrome if its reverse is same as a number. So if you read the number from left to right or you read from right to left, you get the same number, then this number is called palindrome number. And if it's not true, then it's not a palindrome number. For example, 78987. If you read it from left to right, you get the same. If you read it from right to left, you get the same. It's a palindrome number. 8668, again a palindrome number. If you read from right side, 8668. 8, a single digit number is always a palindrome, because if you read it from left to right or right to left, you will get a single digit only. Now this number is not a palindrome because from right to left I'll get 12, right? From left to right I'm getting 21. This number is also not palindrome because if I read from right to left, I'll get 763, which is not same as 367. Now please pause this video and try to write down a function that takes a number as an argument and returns a boolean value, which is true if your given input number is a palindrome number, otherwise false. Let us now talk about the idea to solve the problem. The idea is simple. We find the reverse of the given number, then we check if the reverse of the given number is same as given number. If the reverse is same, then we say it's a palindrome number, otherwise not. For example, 367. If you find reverse of it, you will get 763, which is not same as 367, so you will return false. 363. If you find reverse of it, you will get 363, and it's same as the original number, so you will return true. Now the question arises, how do we find reverse of a given number? To find reverse of a given number, we need to traverse the digits from last to first. And traversal of digits from last to first is really easy. We can find last digit of a number by using this percent operator. If I do x percent 10, I'll get the last digit of x, because this percent operator gives you remainder after division with 10. So if I do x 367% 10, I'll get 7. And then to remove 7 from our original number so that we can get 6 next time, we do x equal to x by 10. If I do x equal to x by 10, I get rid of the last digit. So next time when I do x percent 10, I'll get second last digit, right? That's the idea we follow to get digits from right to left side. In every iteration, we are going to get the last digit and then we are going to do x equal to x by 10. So this is how I can traverse through all the digits from 7 to 3. Now, I can traverse all the digits. How do I find the reverse of a given number? I'll initialize the reverse as 0, and in every iteration I'll do reverse equal to reverse into 10 plus 7, whatever the last digit is. For example, the current last digit is 7, then I'll add 7. This way I'll get the reverse first as 7, and in the next iteration I'll get 7 into 10, which is 70 plus 6, the current last digits, right? I'll get 76. In the third iteration, I'll do 76 into 10, 760 plus 3, 763. So I'll get the reverse of the number. Let's do one more example. Here my last digit is 3 and my result is initialized as 0. So we'll do reverse equal to reverse into 10 plus 3. We'll get 0 plus 3, 3. Then we'll come to the second last digit 6 and we'll do 3 into 10, 30 plus 6, 36. Then we'll come to the first digit, we'll go do 36 into 10 plus 3, which is 363. So we'll get the reverse as this. And at the end, we'll simply check if this reverse is same as this or not. In this case, it's not same. In this case, it's same. Now please pause this video and try to implement this approach yourself. Let's now take a look at the implementation. This implementation is almost same in C++ and Java. In Java, we just need to replace this bool with boolean. This function takes an integer n as an argument. It initializes the reverse of this number as 0, and at the end it simply returns return value of this expression. And what is this expression? This expression is reverse equal to n, comparison of reverse and n. If they are same, then this expression is going to return true, otherwise it's going to return false. So we have reverse here, and at the end we are checking reverse and n. In the middle we are simply computing the reverse of given number. Now how do we compute the given reverse of given number? For that we have already discussed the logic. We are going to take the last digits one by one, and then we are going to remove the last digit, and then we are going to update the reverse. But we need our original number at the end, right? So we can't remove the last digit of given number. Due to this reason, we create another number temp. In this temp, we first store n. and then we get the last digit of temp, and then we remove the last digit of temp, so that when we try to get the last digit next time, we have no previous last digits, right? So let's see the working of this function with this example. This is not a palindrome number. At the end, you will get the reverse as 3554, and they are not same, so this expression will return false. Let's see how are we getting this reverse number. So we have initialized reverse as 0, and we have initialized temp as the same number. Now we are removing last digits one by one from the temp, and we are updating the temp, and we are also updating the reverse. So first thing we do is we get the last digit in a variable LD. So LD is last digit of this number 3, and then we update reverse. Reverse was initially 0, now it becomes 0 into 10 plus 3, which is 3. And then we update the temp, temp equal to temp by 10. So last digit removes. Now our temp becomes 455. In the second iteration, we do the same thing. Our temp is now 455. We get the last digit by doing temp %10. We get the last digit as 5. Then we update the reverse as 3 into 10 plus 5, 35. And then we remove the last digit by doing this operation. So our temp now becomes 45. In the third iteration, we get the last digit of remaining number, which is 45. Right? Doing temp %10 will give us last digit as 5. And now we update the reverse. Reverse is going to be 35 into 10 plus 5, which is 355. And then we update the temp. So update the temp, we do temp equal to temp by 10. We simply remove the last digit, right? So we get temp as 4. Now we have only one digit, so one more iteration. Now we get the last digit as 4 by this operation. And then we get the reverse as 355 into 10, 3550 plus 4, 3554. And then we do temp equal to temp by 10. So 4 by 10 now becomes 0. And when temp becomes 0, we come out of this loop. And when we come out of this loop, we have reverse and we have our original number in n. We simply compare these two and we return false. Let us now talk about time complexity of this solution. We are simply traversing through all the digits of a given number. So we can say time complexity is theta of d, where d is the number of digits in our input number.